Good morning, children. Today we are going to discuss about the respiratory volumes. Normally, the very well normal tidal value 500 ml that already we discussed, right? So some more points about the respiratory volumes we will be discussed today. Number one, the first one you see the normal value tidal volume 500 ml. So normal respiratory value, normally respiratory rate. What is that normal respiratory rate? How much? It is absolutely, very well, normal respiratory rate 12 times per minute. Okay, 12 times per minute. The volume of, the volume is 6 liters per minute. The respiratory volume is 6 liters per minute. So important bits ma, very should listen very carefully from one words. So first what we are discussing, discuss tidal volumes, expiratory reserve volume, inspiratory reserve volume, and vital capacity, total lung capacity. Like that in the last class, previous class we discussed. In this class, what we will be discussed is just some important exchange of gases and respiration, what is dead space. These all the things we will be discussed. Come on, one by one. Normal tidal value how much? 500 ml. Normal respiratory rate 12 times per minute. Respiratory volume 6 liters per minute. So that one you should have to remember. Next, dead space. What is this? Dead space. Some of the inspired air, inspired means you are not taken air, never reaches the gas exchange areas. Some of the inspired air never reaches the gas exchange areas but fills the respiratory passages where exchange of gases does not occur. So some of the inspired air never reaches the gas exchanges area but fills the respiratory passage where exchange of gases does not occur. So fills the respiratory passages where exchange of gases does not occur. That is called dead space. So this airspace is called dead space. Dead space is not involved in the gases exchange. Okay, very important. Approximately, its amount is approximately 150 ml. What is a dead space? Which one is not involved in the exchange? So there the air will be there. That is approximately 150 ml. Observe very carefully, children. We are discussing the dead space value. Some of the inspired air never reaches the gases exchange areas but fills the respiratory passage where exchange of gases does not occur. First point. This airspace is called dead space. Dead space is not involved in gases exchange. Its amount is approximately 150 ml. So dead space air or dead space is not involved in the gaseous exchange. Okay, that is important. Next, exchange of the gases. Exchange of the gases we are going to discuss. The primary site for the exchange of gases is alveoli. So the uptake of oxygen and the release of carbon dioxide occur. So uptake of oxygen and release of carbon dioxide between the blood and tissues by simple diffusion. What is a diffusion? What's the meaning of diffusion? The movement of molecules from high concentration to low concentration is called diffusion. So what will happen here? The release of carbon dioxide between the blood and tissues. Between the blood and tissues will be take place. So that is most important point to remember. Okay. So these all the things you should have to remember. So what is it? The primary site of exchange of gases is alveoli. The uptake of oxygen and release of carbon dioxide between the blood and tissues by simple diffusion. So that is simple diffusion. So uptake of oxygen, release of carbon dioxide between the blood and tissues by simple diffusion. So driven by partial pressure gradients of oxygen and carbon dioxide. How that movement is going on? The partial pressure gradients. What you call partial pressure gradients? Because of partial pressure only. Okay, suppose mixture of gases are there. In that one gas, how much pressure it will be created? That is called partial pressure. So partial pressure contributed an individual gas is a mixture of gases. Partial pressure means contributed by an individual gas in a mixture of gases. Suppose oxygen contributed how much pressure? That is called oxygen partial pressure. So we can write like this: PO2 oxygen partial pressure, PCO2 carbon dioxide partial pressure. Due to pressure gradients only, O2 from the alveoli enters into the blood and reaches the tissues. CO2 enters into the blood from the tissues and reaches alveoli for the elimination. Oxygen is entering, carbon dioxide is eliminating outside because of the pressure. Once again, children. So primary site of exchange of gases, what it will be? It will be alveoli. What is alveoli? Alveoli is the site of exchange of gases. It's a unit of lungs where the exchange of the gases will be takes place. Alveoli. So alveoli is very useful for the what you called exchange of the gases. Next, uptake of O2 and release of carbon dioxide between the blood and tissues by simple diffusion. Uptake of O2 and release of carbon dioxide between the blood and tissues by simple diffusion. It's a partial pressure gradient. So mainly this simple diffusion, how it is going on? Because of partial pressure gradient O2 and carbon dioxide. The partial pressure contributed by any individual gas in a mixture of gases. What's the partial pressure? How can you define the partial pressure? Any individual gas gives the contributed an individual gas in a mixture of gases. That individual gas, how much pressure it will be create, that will be called partial pressure. So oxygen partial pressure, how can you write? What is the symbol? So this is very important. Partial pressure, PCO2 partial pressure oxygen, partial pressure carbon dioxide due to pressure gradients. O2 from the alveoli enters into the blood and reaches the tissues. CO2 enters into the blood. So this is important. Partial pressure of oxygen, partial pressure of carbon dioxide. Due to pressure gradients, O2 from the alveoli enters into the blood and reaches the tissues. Carbon dioxide enters into the blood from the tissues and reaches the alveoli for elimination. So oxygen entering into the tissues, carbon dioxide is eliminating outside because of the tissues. Okay, because of the what you called from the tissues and reaches the alveoli for the elimination. So this is most important point to remember. So alveoli, so the tissues and reaches the alveoli for elimination. Which one? Carbon dioxide. Next, as the solubility of carbon dioxide, next important thing is, as the solubility of carbon dioxide is 20 to 25 times higher than that oxygen. So solubility of carbon dioxide is very important. So the solubility of carbon dioxide is 20 to 25 times higher than that of what you called the 20 to 25 times higher than that of O2. So the partial pressure of carbon dioxide is much higher than that of oxygen. So that is important. The partial pressure of what you called oxygen, the partial pressure of carbon dioxide is much higher than that of O2. So solubility of carbon dioxide is 20 to 25% higher than that of O2. And even partial pressure of carbon dioxide solubility and carbon dioxide is much higher than the partial pressure of O2. That's why carbon dioxide easily will be transferred to the through the blood. Next, respiratory pigments. What are the pigment? What is a pigment? Pigment is helpful for the exchange of the gases. Pigment consists of organic part, protein part. For example, you know very well, in our body, one important pigment is there. What is that important pigment? You know very well. hemoglobin. Hemoglobin is the important protein. That's a pigment, not a protein. It's a pigment. What is the function of hemoglobin? You know very well. Hemoglobin is a conjugated protein. So iron containing pigment portion. So heme only 4% and the rest colorless protein globin. So Fe iron containing pigment portion heme only 4% and the rest colorless protein is globin. You know albumins and globulins. Globin. Globin is the part which is the most important histone proteins. In that hemoglobin, globin also there. Color what you called heme also there. Heme means iron containing pigment portion. So heme and globin togetherly called hemoglobin. So this globin is related to which kind of protein class? Histones. You know DNA will be fixed around in the cells. Lengthy DNA will fix in the what you called in the cells because of histone protein. Same like that, this globin is related to histone class proteins. Next important thing is the molecular weight of the hemoglobin is 68,000 daltons. What you called? Very important. The molecular weight of the hemoglobin is 68,000 daltons. In that, 4 atoms. Here the pyrrole. You know there will be 4 rings are there. Pyrrole rings are there. Tetrad. So each 4 atoms of iron will be there in the hemoglobin. Each atom, iron atom, combined with the oxygen. So 4 atoms will be there. Each atom will be combined with the which one? Iron. So each atom will be combined with the iron. So each combined with the oxygen. So iron. So 4 atoms of iron, each combined with the oxygen. So for what is the reason oxyhemoglobin will be there or not? So for the transportation of oxyhemoglobin, the iron joins with the oxygen. Next, methemoglobin, another important pigment that is called methemoglobin. Methemoglobin, iron component of heme moieties. Methemoglobin, iron component of heme moieties, is a ferric state. Okay, iron component of heme moieties. It's a ferric state. The normal ferrostate, but it's a ferric state. So this does not, ferric means does not bind to the oxygen. So RBC contains less than 1% of methemoglobin. So RBC contains how much? Less than 1% of what is called methemoglobin. This point also very important. Okay children, observe very carefully. We are discussing the respiration related what is called the concepts. In that yesterday we discussed about volumes. Different volumes we discussed, right? So normal tidal volume 500 ml, normal respiratory volume 12 times rate per minute. Okay, respiratory volume 6 liters per minute. These are the bits. What is dead space? Some of the inspired air never reaches the gas exchanges area but fills the respiratory passages where exchange of gases does not occur. So gases exchange does not occur. That space is called dead space. Dead space is not involved in the gases exchange. So it amount to approximately 150 ml exchange of the gases. Primary site of exchange of gases is alveoli. So uptake of O2 and release of carbon dioxide between the blood and tissue by simple diffusion. You know diffusion membrane. What is the diffusion membrane? Number one, you know, come on, what is the diffusion membrane? The epithelial cells of alveoli, the endothelial cells of blood capillaries, basement membrane, epithelial cells, endothelial cells, and basement membrane. So these three togetherly called diffusion membrane. Minute 1 millimeter, very less, very thin size. Through that only diffusion process will be takes place. And also partial pressure gradients. Partial pressure means you know very well one particular gas. So partial pressure gradients of oxygen and carbon dioxide. Partial pressures What is the meaning of partial pressure? That is important. Partial pressure means it's contributed by an individual gas in a mixture of gases. An individual gas in a mixture of gases. So partial pressure of oxygen, partial pressure of carbon dioxide due to pressure gradients only. What will happen? O2 from the alveoli enters into the blood and reaches the tissues. Carbon dioxide enter into the blood from the tissues and reaches alveoli for elimination. So one is entering, one is eliminating because of the partial pressures of oxygen and carbon dioxide. See how much oxygen pressure is there? That is oxygen partial pressure. How much carbon dioxide pressure will be there? That is carbon dioxide partial pressure. As the solubility of carbon dioxide is 20 to 25% times higher. So the carbonate solubility is 20 to 25% time higher than that of O2. So that's why carbon dioxide maximum bicarbonate form only that will be transferred to the outside. Next, partial pressure of carbon dioxide is much higher than the O2. See, solubility is more, even partial pressure of carbon dioxide is also more than the O2. So that's why there will be two important points we have to remember. So partial pressure of carbon dioxide is more, solubility of carbon dioxide is also more. So these are the things you should have to remember. Next important points to remember is respiratory pigments. What are the respiratory pigments also we discussed. So there are different types of respiratory pigments. I said hemoglobin. It's a conjugated protein. What is a hemoglobin? What is a hemoglobin? It's a conjugated protein. Iron containing pigment portion. Heme only 4% and the rest colorless protein is globin. Only 4%. Remaining all complete globin only. Just heme iron containing pigment portion. 4. Histone class. Molecular weight 68,000 Daltons. So 4 atoms of iron each combined with okay, there will be 4 atoms of iron is there, each combined with oxygen. Methemoglobin, iron component of heme moieties, the ferric state, the normal ferrous state, does not bind to O2. See, methemoglobin, here what 4 atoms of iron each combines with oxygen for transportation in hemoglobin. What about methemoglobin? It's an iron component of heme moieties. Iron component of heme moieties only methemoglobin. But it's an iron component is a ferric state. Actually ferrous state. Ferric state means will not bind to the oxygen. Does not bind to the oxygen. So RBC contain less than 1%. Very important need bit. RBC contain less than 1% methemoglobin. So like this, the hemoglobin, methemoglobin, like that pigments are there. So diffusion is the important process of exchange of the vertical transportation of gases and hemoglobin, carboxyhemoglobin, oxyhemoglobin. So 3 ways the exchange of gases. One is through the plasma, another one is through the hemoglobin, another one is in the form of bicarbonates. Okay, in the form of bicarbonates, the gases will be transported. 97% carbon dioxide transferred through bicarbonate form. So these are all the points you should have to remember. So what are the neat points in this? Neat points. First neat point is what? Here. What is the neat point? What is the tidal volume? Normal tidal volume 500 ml. So like that. What is the respiratory volume? 6 liters per minute. What is the molecular weight of what is called hemoglobin? 68,000 Daltons. What is methemoglobin? Ferric state, ferrous state. So ferric state iron component of heme moieties is called methemoglobin. It will not bind to the what is called oxygen. So what is the PO2? What is the partial pressure? Pressure contributed by an individual gas or is the mixture of gases is called partial pressure. Like that, the neat bits also there. Here what is there? Another important, what is heme and globin? Heme is the iron containing pigment portion, only 4%, and the rest is what? Globin. It's a globin. What is the next bit? Globin is related to which class of the protein? Histone class of the protein. Like that, Even neat bits also will be there in this concept.